Hey, what's up? This is Jake here in Jake's shop. So, gonna do the next thing on bodywork panels. You know, obviously the Camaro and what we're doing here, got a lot of that going on. I'm gonna go ahead and do a patch panel in the bottom corner of this fender. I did one on the other fender as discussed in the previous video behind me. Got that into primer, did the patch panel. I did a ton of bodywork to that. So this will be the next segment and how I've got the old fender in after the panel prep stage. It used to look similar to this one, to one that looks more like the one behind me. So yeah, these are going to need a little patch panel in the corner, and I'll show you. I'll zoom in. We'll take a closer look into that, and I'll explain to you what I'm going to do to patch that panel in. Okay, so here is the culprit. We've got the fender here, and you know, these fenders can be a lot worse. Actually, the other fender that we did, that I did earlier, was worse than this side, but still there's a problem here. You know, there's just enough pitting in here that, you know, some guys might try and rust mort that. It's solid, you know, there's no chunky, flaky, nothing going on there that's really scary. Some guys might try and rust mort that in. I don't need, you know, I can feel it. It's pushing up, and I know that there is a support under here. See this structural support in here. A lot of times, you know, there's no weep hole here. There's no way moisture can get down inside the structural member where this is basically touching the fender, and rust builds up back here. And you're going to see what happens when I take this off. There's going to be rust on this back panel. I know it. I can feel it. I don't know if you're going to be able to see it, but I can feel it pushing up on the metal. It means rust is building up behind this thing, and it's starting to push it out ever so slightly. You know, if there's holes in here, that's a way bigger deal than what we're dealing with. This is just a little patch panel. You know, if there's holes in here, you need to look at replacing the structural brace. I mean, there's a lot more to it. This fender's in pretty good condition, well, for the most part. I would almost not reuse this fender, other than I love the idea, as I discussed in earlier videos, that it's, you know, it's original sheet metal. It's 50 years old, but this nose is just horrid. You know, someone filled this with mud. The bodywork actually was okay on the outside of it, but it was too deep for me. I did a hammer and dolly video in the previous video, but there's going to be a lot of hammer and dolly. I'm going to get all this old Bondo mud out of here and reshape it. I have to the hardest part's going to be, you know, reshaping this nose. You know, I'm probably going to even weld in more metal in here and thicken it up a little bit and really reshape that thing. The body line is there. The other fender had a huge crease in the body line here. This one's definitely got just, it's, you know, dent, 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 dent. That's a dent. That's pretty, oh, there's a low spot here. Low spot here. You know, these old fenders, you're just going to find that, you know. I'm so happy I don't see rust. With the 3 coats of paint we took off of this thing, it's pretty phenomenal. There's a whole low spot here. That's going to be a good one to heat shrink. I could probably bring that almost all the way out with a little bit of heat. So yeah, I did a lot of that. You know, I did areas on that fender. I heat shrunk low areas. I used a hammer and dolly. I just took my time and used my hand. My hand was my eyes to feel. And after that's done, you know, if you can't really feel the dents, you know, after a while you can really feel them, but if you can't really feel the dents, after you've done a lot of hammer dollying, you've repaired your patch panels, and you know where that's at, you know what you're going to need to do there with a little bit of different things, which we'll go into future videos. You can actually shoot a light layer, a haze layer, or a guide coat they call it, with like Krylon or something, you know, something cheap and easy to get your hands on, and just shoot a light layer on it and then block it lightly with like 120 or something, and you'll see the areas that will have the haze of the guide coat on it that are deeper, you know, that you can look at. That's how you're going to make decisions on what needs mud and what doesn't, or filler. And anything that's too low, you know, Duraglass. But we'll do another video on Duraglass later. So for now, we're just doing patch paneling, and here it is. Here's the area I'm looking at. These are, I believe, were because on some of these cars they had a metal chrome trim piece along the bottom. So I'm going to weld those completely solid as well. It's just a hole and a hole. So anyways, we'll go into marking, cutting out, and how I'm going to put that patch panel in. Okay, so I'm going to show a little bit the patch panel. So basically I measured the area that I wanted to cut. It's basically like a 3x4 area. Nothing special. I just got a piece of black iron steel here. 18 gauge is what I'm using. It's about the right thickness, at least when I tested it before. You know, there's really no guarantee of the exact thickness in that area, but it worked perfectly before, so 18 works. You know, you can use a lot of different things to well, first measure. You know, I just used a square and a pen, and I've got the, you know, I took some measurements on that area that I want to cut out. So I want to use that as a template to scribe out and mark the exact area that I want to cut out, so the butt welds are pretty clean and crisp. So after I've marked it out, I'm going to go ahead and cut it. Now you can cut it a few different ways. Metal is actually, I don't know, I've got a little bit of experience working with metal, but you know, you've got your 1/4 inch die grinder with your grinding wheels. Those work pretty good. You know, getting a nice straight line is fairly easy with these for the most part. You can use the big death wheel on the grinder, on the die grinder, which I've used in previous videos when I've been doing the floors and whatnot. But I'm going to go ahead, since it's 18 gauge, go ahead and use a pair of offsets or tin snips. They're called a bunch of different things. Now these are offset tin snips. They make straight ones, they make right angle ones, straight ones, left angle ones, what have you. These are a right angle offset. Red is right, green is left, and yellow handles usually mean straight cut when you're talking about sheet metal shears or offsets. An offset shear, you can see, has the offset in it. The foot is actually offset. I find offsets are much easier to use when you're cutting metal. I'd say within the last 15 years or so in the metal industry, offsets are a lot more common, even though you still can get the ones that aren't offset, which, you know, I think I have a pair I can show you over here that are not offset. These are a right angle cut, technically, but they're not an offset. You can see that, the difference. The nice thing about the straight, or the right angle, the right ones that are straight, is they can usually cut, they are a little easier to cut thicker metal with. 18 gauge is not light. 18 gauge is not easy to cut with a hand pair of shears, but I can do it. I should be wearing gloves as well. This usually creates sharp corners, and whenever you use offsets, you know, you're not using them like, you're kind of using them like a scissor, but you need to get the metal in, cut, get it back to the throat, cut again, back to the throat, cut again. If not, you're going to see all these little hangers, and you call them hangers, sheet metal hangers, but it's going to be these little tears coming up, and it'll cut you, it'll make a mess of things. So I don't know. I'm using offsets mainly for the video to show an offset, and I like them. It's quiet. It's a nice, clean, crisp cut. The downside of offsets is obviously you're limited on how thick the metal can be. Also, on any sheet metal shear, you're going to run into issues with the metal's going to bend a little. You know, the offset naturally wants to make it so that you are gonna, it's just kind of tweaking out of your way. You know, it's like a scissor, right? It's pulling out of your way. Now I can kind of show you that after I cut this. So now it's cut. Now that's it. You know, that's 18 gauge. That's pretty thick metal. Most cars are not made, well, new cars are never made with this thick of metal. Most of the metal on this car is 18 gauge, 20 gauge, depending on exactly where it's at. There's some 16 gauge in there as well, which is thicker. So the smaller the number, the thicker the metal. But basically what has happened here, as you can see, it's warped a little bit, right? I don't care about warpage. You know, it's a piece of metal. It can be hammered out. It can be flattened out. No big deal. I got a nice steel table here. And when you're pounding metal, a lot of times you want to, you know, it's that's a slow version where you kind of drag, drag, drag. It's pulling the metal out. It actually helps molecules flatten it out. So you can already see it's already starting to flatten out a little bit. At the end of the day, I don't want this flat either, because on that fender, it curves in. So what I'm going to do to curve it is pretty simple. I know roughly what I want for a curve. It's not going to be perfect. Right now I'm just trying to get an idea. So I've got it on the edge of my table, and I'm just going to try and give it a little bit of a bow to it. That's really what I'm trying to do right now. And I know that the very bottom edge of that is an extreme bow. So I'm gonna bring this out slightly. I'm just gonna bow it down a little bit. You know, this is all rough work. You can kind of see that, hopefully you can see that. is bowed in a little bit at the bottom. That's going to mimic the bottom of that fender, and then the rest of this needs to start having a little bow in it. I'm going to create that bow by basically using this method. After I create this bow, I'm going to test fit it on the fender. I haven't even cut the metal out yet, and just try and get it pretty close before I go to cut that out, you know, because I want to use it as a really good scratch. So I'm going to go back and forth, test fit, pound it, shape it. You know, you can use anything that's round. I actually use my vise, which you can't see in the camera right now. It's got a rounded back edge on it, and I'll put this on the side of it as well, and just tap it and tap it and tap it, and try and form it in a way that is close to that. You know, it doesn't need to be perfect. There's going to be filler in there, but I want to get it really close. I don't like deep filler, and I really want this thing to fit properly. So that's some of the methods I'm using just to cut this out and get my initial shape in. Next video, we'll cut a clip. I'll show you what I'm going to do to cut this thing out. Okay, so I pretty much have that panel worked out. You know, it didn't take much. There's a little bit, hopefully you can see this okay, but there's a little bit of curvature in here, right? And this is the area that we're going to be replacing. So I've got that edge pretty much the way I want to see it. I've got a little bit of a curvature to kind of mimic what's going on here in the corner. Now I've got this set. You know, and that's kind of the area I'm looking at putting that patch panel in before all is said and done here. So this is going to be my guide, basically, so that I make sure that no matter what, it's where it needs to be when I cut it out. Now, when I go to cut this, you need to be very careful, because as previously in this video, you saw the there's a structural member behind this fender. Now, so when you go to cut this out, you need to be very, very ginger when you're cutting it. I'm not going to bother show cutting it, because I know you're not going to get anything out of it really, but I'm going to use my 1/4 inch die grinder that I showed earlier to cut this out. And I'm just going to be very, very careful when I cut this out. And, you know, there's the line. I'm going to cut slightly to the inside of the line all around this. And in the corners are the hardest to deal with. You can overcut them slightly because you can weld them back into place when you're cutting this out. But you just got to be very careful. You know, on the previous fender that I did, I got them really, really close. And then I was actually able to get in there with a sharp knife and kind of whittle it out so I didn't have to overcut these corners too much. Because obviously you've got this round disc, and it's just not going to, you know, you can only get so deep. Otherwise, you're going to, again, be in the structural member over here. And this member, you know, the structural member is about this wide. Back here, you're going to have a wide open area on the back side of the fender. Under here, again, the same thing. I'm going to cut slightly to the inside of the line, because at the end of the day, if it doesn't fit right, it's not going to fit right the first time. I can guarantee that. But it'll be very close. So what I'll do is, after this is cut out, is I'll shape this piece perfectly, test fit it, shape it. And what I'm going to use to shape it is actually going to be a flapper disc on my 1/4 inch grinder. This takes off a little bit of metal, you know, and I'll be just cleaning these corners and getting it, you know, I'll check it. Okay, what's hot? What's in my way? What's in my way? And I'll clean the corners, and it takes off just ever so slightly bits of metal. So I'll go ahead and cut this out. I'll show you what this looks like underneath here. You're going to be very surprised at what you're going to see underneath here, and that's why the right way to do things, you know, I can guarantee you there's an issue here, even though it doesn't really look like it. There's no holes. You know, if I painted that and did body work and did this beautiful paint job on this car, it probably wouldn't even show a problem for 10 to 15 years. But I know what's there. And again, this is going to take me a few hours. Nothing in materials. I mean, you know, sheet metal is pretty cheap, at least, you know, if you go to a sheet metal shop and go buy some sheet metal, it's cheap. It's very, very cheap. And this took me not very much time at all. You know, I'm going to actually be using a TIG welder. You can use a MIG as well. There's nothing wrong with a MIG at all. A TIG is just a little less sparks, and since I have so many chemicals in here right now since I've been painting, I'd rather not have slag jumping around. But at the end of the day, it doesn't matter. You could TIG it in as well using a light gauge wire. So we'll cut this out. We'll show you what it looks like afterwards. Okay, so I got this pretty well cut out for the most part. I hope you can be able to see this, but I just cut this out. Now, I haven't even taken this out yet, but I'll go ahead and look at that. So this is what builds up between the panels. You know, there's no holes in this piece at all. and it looks solid. But in between here, there's that structural member that's underneath, and you can just see this is mostly dirt. There's also rust in there, you know, and it's just going to slowly eat away at the underside of your panel. This is why these corners are so important to take out, even if you don't see pit holes or rust really prevalent in them. And that's the area. I'm actually going to also drill a hole in the bottom of the structural member, and it's really just going to be a weep hole before all is said and done. But how do you deal with that? What do you do? So I've got my new piece, obviously, that's going to be welded in there, you know, eventually once I trim it to fit. This needs to be, you know, I'm going to dig this all out of here. I'm going to use a wire wheel. I'm going to use a flapper disc. And I'm going to dig all of this out of here. And then after this is all cleaned up, all dug out, and I've got, you know, the wire wheel and, you know, I'll probably use a flapper disc and just clean all of this out of here. I'm going to rust mort it, actually. I'll do a combination. You know, I can use the industrial grade stuff that I had showed earlier on videos, but also just the, you know, any kind of rust converter is better than nothing. Once you've dug it all out, the problem is when you go to weld this piece in, most of whatever's in here is going to burn out. I know they make this stuff that's like a supposedly some sort of weld-through primer. I have no clue what that stuff's about, and it doesn't make any sense to me because I don't care what you spray on here, no matter what, it's going to melt out or burn out once you hit this with welding. But rust converting is better than nothing. It'll get to areas that the heat probably won't eat things out on, and at least then I know that there's no rust in here. It'll be better than it was from factory, and it'll be gone. So I'll go ahead and clean this the rest of the way up. I'm gonna use I'm gonna use my flapper disc. I'm gonna use a wire wheel on a 1/4-inch grinder and clean all of this up, and then I'll go to fitting this panel in. Now, when you go to fit this in, obviously it still doesn't fit. It's still slightly big, right? Well, and that's because the 1/4-inch wheel on the cutting disc is not perfect. Couple things I've noticed that's helped me out. I've got these files. This is actually a triangular little square file. And in the corners where I wasn't able to get the cutting disc perfectly square, you know, I can get in here and just file them nice and square. You know, these corners are going to be harder because there's a structural panel in the way. So on those ones, you know, I'm just going to work them down with like a chisel, a knife, something fairly sharp that can just kind of clean the corners up, you know, after the rust is out of here. And then after that, I'm test fitting the panel. I'm doing it over and over and over again until it fits perfectly. I mean, it's pretty close, but I definitely need to do a couple things. I've noticed if I round the corners of this panel off slightly, it helps make the fitment easier. You know, a slight gap you can weld shut. You know, especially with a MIG, it's really easy. A TIG, I actually find the TIG a little easier on something this light gauge because I can flow it. I can flow it in there. Make sure, you know, you're not just welding on the top of this. You're actually melting the metal together all the way through. You're getting really good penetration because you're going to be grinding a lot of that weld off to make this as smooth as possible. So you can get your Duraglass product or, you know, filler over it. So I'll go ahead and clean the rest of this up and then kind of show you the fitment and maybe how I would tack something like this on. I'll probably be using my TIG like I said earlier, and I'm still practicing TIG, but MIG would actually be slightly easier probably, but same basic process. Just get it clean, get it clean, get it clean. We'll show the next step. Okay, so we're going to go ahead and show you what this did. So it's the next night in the shop, in here doing some work, and I was able to get the patch panel pretty much fit. Like I said in the earlier clip there, I just shaped it, used that flapper disc to shape it, and, you know, put it in, take it out, take it in, take it out. It's the next night because I went ahead and sprayed rust mort in this. It's phosphoric acid, but sprayed it in there, let it sit overnight, 24 hours solid, and then I went back through with my wire wheel here and just cleaned it all up really well, hit it with the flapper, you know, clean the edges with the flapper pretty well. So now I'm getting ready to take this in. I'll probably go ahead and time-lapse it, getting it tigged in. You could use a MIG, you know, 023 wire, even an 030 wire. It wouldn't really matter, but I've got that thing to pretty much fit perfectly in there. So that's really what's going to happen. Now, what I'm going to do, just like with a MIG or a TIG, you know, I'm going to spot weld it in a few areas. And as I'm spot welding, the metal's going to move a little bit. If it pulls up or pulls down a little bit, I'll use a flat tip screwdriver and kind of push it into position and tack it again. I'm going to use a magnet on the back side of this panel to hold this new panel in position as I tack it around. And the reason, because I have a TIG, I'm going to go ahead and use it is because I can kind of flow it better. You know, I'm not stacking dimes on anything like this. I'm really just trying to flow it in there, you know, make it one solid piece of metal, get these two pieces to match. Like earlier in the video, this is 18 gauge, and you know, it really fits in there perfectly with this edge. You know, where that structural member is touching it on the backside. So I'll go ahead and we'll tack it up. We'll shoot a little time lapse, and then I'll grind it. You know, a lot of anything that's high, I'll be going back with my flapper, and I'm going to grind it all smooth. And that'll kind of go through this process of putting that patch panel in. Okay, did a little time lapse there. I'm gonna wrap up the patch panel video with that. Basically, that's TIGging. It's a slow process. That probably took me 20 minutes on time lapse. It zips right by. But you know, tack in the different areas. You know, I could have actually reduced some warpage, but if I had a wet rag and I was squelching it. But in that area, it's pretty thick. There's that body seam in there. The edges are in there. I wasn't too worried about warpage. If I was doing a panel in a big flat spot, I'd probably be quelching it as I went, just keeping that warpage down. The nice thing about TIG is it's a lot like a torch, right? I've got oxyacetylene torches. I actually used to do a lot of that, and doing little panels, you can get really fine-tuned with a torch. You know, you can flow it in there. You can kind of flow that gap. MIG would have worked as well, you know, especially on a lighter metal with a light gauge wire and the MIG using a 023 wire or something, you could have done it. I find that that's a little easier on that thinner sheet metal, especially with a butt weld. If you were going to do a lap weld, it'd probably be, you know, way easier, you know, especially if you're doing big panels, you're doing a lap weld. MIG definitely be quicker and a lot easier. But TIG gives you a little more flexibility, especially when you're dealing, you know, this is kind of the final of it for now. Again, I want to make sure it's lower, and so it's just ever so slightly lower than the remainder of the panel, because there's going to be some filler in here. You know, I'm not going to get away from filler on that. I don't want to try. If I probably could have if I really spent forever on that one little panel, but I've got, you know, hundreds and hundreds of hours of body work to do this car right. So that's a great way to do this. I wouldn't probably use lightweight filler in this either. It's going to be low enough to where if it's starting to get close, a little over 1/16, close to an 1/8 inch thick of filler, I'll probably need something, especially on a weld. I'll coat that first with Duraglass. So I'll do another video in a couple weeks on the Duraglass product, you know, kind of similar to what I did to that fender behind me. And go from there. So hopefully this was a little bit informative or fun to watch, or you learned something, or at least what I'm doing. You know, I'm got a long ways to go with my TIGging. But it's fun, you know, just kind of practice and do it, and practice and do it. You know, I'm got a little hot under the hood because holding it's hard. Oh, the one thing I did that I think's cool about this TIG that I actually added to it as an upgrade. Most TIGs have a foot pedal, if you're familiar with TIGs at all. I actually went ahead and did a torch handle trigger on this. This is actually a belt style that you can roll back and forth and variable the voltage on it as you're doing it, so you have complete control, you know, unlike a gas welding or something where you're setting the gas or changing your tips and your pressures and you're constantly adjusting it. This one you can just do on the fly, you know, it's electronic. It's what a TIG, that's so nice about a TIG. But that torch handle is great. I'm able to get into things without having to worry about where my foot's at or set up to where I can get on something with a foot pedal. So hey, if this was fun at all to watch, go ahead and hit like and subscribe. I'll keep making videos, and we'll go from there. Thanks.